everybody. Thank you for coming to this talk. It's great to see so many people interested in Java APIs. My name is Miro Cupak. I'm with a Toronto-based company called DNAstack, and our mission at DNAstack is to improve lives of people affected by genetic disease. And we try and do that by developing standards and technologies for search, access, and analysis of biomedical data. And if health tech is something that you're interested in or curious about, please come find me after the talk. I always enjoy talking about it. But in this session, we're not focusing on this particular domain. We're focusing on the underlying technology stack, which of course is Java. So you can think of this session as essentially sort of an introduction to Java API design meets what's new in Java in the last couple of years. We'll learn from the best, the JDK itself, and we're going to take a look at essentially new or updated APIs that introduce some sort of an interesting pattern or replace some old clunky functionality with some sort of a better approach that allows us to make our code a little bit cleaner. In particular, sorry, question? Can I turn the volume on? Oh, okay. That's not me controlling this, so whoever did this, thank you. Okay. All good now. Perfect. Great. So we're going to take a look at these 4 new APIs and their older counterparts, which we all know and probably don't love. We'll start with something really basic and well-known, that is, of course, the Collections API, and then sort of build up to more and more complex and more niche things, including the Stack Walker, the Process API, and the new HTTP2 client. I like learning through examples, so this is going to be a very example-driven live coding kind of talk, and I'm going to write my examples in JShell. So let me just switch to my terminal here, and we can start with the first API, which of course is Collections. Now, before we proceed, how is the font size here? Is this readable in the back? Perfect. All right. So, changes in the Collections API that we're talking about here are from Java 9 and 10. And Java 9 and 10 basically improved our use of immutability when it comes to collections, which is something that was relatively tedious to do with the previous releases of the platform. And we all know the drill, right? If I wanted to create, let's say, an immutable set prior to Java 9, I would probably do it sort of like this. Let's create a new set, let's say, of integer, and let's call this a set, and make this an interface. Then I would add a couple of elements, let's say something like this. And then finally, to make it immutable, I would wrap it in collections, unmodifiable set, and assign to the same variable here. And this, of course, works. We've all done this many times. But there are a few issues with this approach. First of all, this approach is pretty verbose, right? I just wanted to create a very simple immutable collection, and I needed, like 5 lines of code to do that. The fact that it's not a one-liner can get a bit annoying. If you're dealing with static collections, for example, you need to do static initializer blocks, which is not exactly fun. And on top of that, this isn't even a truly immutable collection, right? This is more like an immutable view of the underlying collection. But if I kept the reference to the original set, I would still be able to modify it, which is why this idiom is very common. Wrap in unmodifiable and assign to the same variable so as to lose the reference. There's also performance overhead associated with this approach. There's performance overhead related to supporting mutability in the underlying collection. So this, obviously, very basic, very popular construct, but you can see that it's not exactly ideal. So how can we make this better? How would you address some of the problems that we described? Any ideas here? Yeah? Yeah, set that off. Great idea. Java 9 introduces new factory methods that allow us to deal with this problem. Out of curiosity, how many of you here are still on Java 8 or maybe even an older release? Oh, wow. OK, vast majority of people here, which is interesting and very 6 years ago of you. But that is OK. I'm sure we can all relate to this pain. It's obviously, it's not easy to upgrade in an enterprise. I work at a small startup, and we still have a couple of services running on Java 8 because of third-party dependencies. Not for long, but currently still the case. No shame in that. But even if you are on Java 8, there are ways of addressing some of the problems that we've described, right? There are approaches particularly that help with verbosity. How would you make this a one-liner, for example? Can you think of any ways I would make this a one-liner? Any ideas? Well, one option here is to essentially pipe it through an external data structure. So typically what you would use is maybe arrays as list. Let's give it a couple of elements. And then, of course, the only method that we have in arrays is as list. So if I want to make this a set, I would have to wrap it in a hash set. And to make it immutable, I would have to wrap it again in collections, unmodifiable set, maybe something like this. And one too many brackets. Oh, no, I'm actually missing a bracket here. Here we go. This, of course, works, and it is a one-liner, but otherwise still pretty much all the disadvantages that we had with the previous approach, right? Still not truly immutable, still performance overhead. This is actually kind of annoying because even though it is a one-liner, there are quite a few things going on the same line. I'm going through an array to a list, to a set, to another set. So not ideal. A similar approach to this, you could do it through streams, right? You can pipe it through streams, stream off, pretty much the same set of advantages and disadvantages. And finally, there's also this instance initializer construct, which is a little bit more extreme, but I want to show it because I think it's a very interesting construct. So to use that, I'm again going to start with collections unmodifiable set. And here, I'm going to create a new hash set, integer for consistency. And I'm going to use this sort of double brace construct here. And inside, I'm going to initialize it as you would expect. So something like this. And this works as well. Just out of curiosity, how many of you have actually seen this before? Okay, very few people, and not surprisingly, this isn't exactly something that you should use. The reason that you shouldn't use it, pretty much the same set of disadvantages that we had before when it comes to not being truly immutable, and it is a one-liner, but still not exactly readable, a bunch of things going on here, and the same performance penalty. But in this case, it's even worse, right? Because this costs an extra class at each usage, and you're actually holding references to the enclosing instance, so you're potentially also risking memory leaks, which is why you don't usually see this in real code. But it is certainly an option. And finally, another option, and this is something that I used to do myself for many years, and kind of my go-to option, is to use an external library. My favorite one is Guava, and Guava gives you a very nice API where you can create an immutable set just like this. And you can see that this really is a proper one-liner, very concise, very readable. It is actually truly immutable, and it doesn't have the performance overhead that we had with the previous approach. So arguably, the best option out of the ones that we've seen. But of course, it is expensive in its own way because it requires you to pull in external dependency. So not ideal. But the bottom line is that creating immutable collections in Java, particularly when you try to do it with the JDK itself, typically involves a lot of boilerplate. And the trouble in the boilerplate doesn't end here. If I wanted to create, for example, a copy of my set, which I would also expect to be immutable because my original is immutable, I would probably do it like this, right? The default way of doing this in Java is to use the copy constructor. So you can do something like this, give it my original set, and let's call this set2 and make this an interface again. But now, if I try to add something to this set, you can see that this easily goes through. This is mutable again, because this is just a regular hash set, right? So to make it immutable, again, Java boilerplate here, I would have to wrap it in a modifiable set. And now finally, if I try to add something, of course, it doesn't go through. So a lot of boilerplate all over the place. And this boilerplate problem that we have on our hands essentially has two parts. There's the creation of immutable collections, and there's copying of immutable collections. Or rather, I should say, creating immutable copies of collections. Now, Java 9, as our colleague correctly pointed out here, of course fixes the first part of this problem, which is the creation of immutable collections. And Java 9 does that by providing static factory methods on all the main interfaces, list, set, and map. So if I wanted to take advantage of this feature, which is now available in the JDK, I can just create my set like this, and this would work just fine. This probably reminds you of what we just saw with Guava, and maybe a coincidence, maybe that was an inspiration, certainly wouldn't be the first thing. However, if we take a look at this method here, you can see that it's overloaded quite a few times actually, 12 to be exact. So it's 0 to 10 arguments, and then a single vararg method at the end. And you might be thinking at this point, why are we polluting our API like this, right? Surely the last case, the vararg version, captures all the other cases. And that's exactly right. And the reason we're doing it is, again, performance. There's performance overhead associated with allocating the array to back the vararg. so we're creating reasonably small collections, which presumably is the vast majority of use cases. You want to avoid this penalty. The API for a list is, of course, exactly the same. For a map, it's a little bit different here. If we take a look here, and you can't see it well because of how large my font size is, but there are only 11 methods here. So it's 0 to 10 arguments, or 20 in this case, because you specify keys and values one after another. But the point is that there's no vararg method here. And the reason that there's no vararg method is because keys and values can have different types, and you can't have two varargs in a single method signature, right? So what they did here instead is they provided an alternative method called ofEntries, which takes a single vararg of type map entry. And if I want to take advantage of this, I can just create my map like this, and this gives me a map where key is an integer and value is a string. So that's Java 9. Fixes the first part of the problem, the creation part of the problem. Java 10 fixes the second part of our problem, which is the copy problem. And Java 10 does that in a very similar fashion by providing copy of static factory methods on all the main interfaces. So if I wanted to create a copy of my set, I can just do it like this, and let's call this set2. And now, of course, if I try to add something to it, immutable out of the box. Similarly for a list, in fact, this is actually a little bit more flexible in that you can use this copy of method to sort of convert between different collection types. So this gives me a nice immutable list right out of my set. And then, of course, for a map, we have a similar method, but this only takes another map because you have to deal with keys and values in some way. And that's not all. Java 10 also tied this nicely with streams by introducing collectors to immutable collections. So starting with Java 10, if I construct a stream here, maybe just from my set, I can call collect to unmodifiable something, let's say a list, and I get immutable collection right from my stream. So basically what this means is that starting with Java 10, we can have immutable collections everywhere, and it is something that we should take advantage of. It's a good practice to create immutable collections by default and only add mutability when needed, which is not what people traditionally used to do in Java, right? Just because it was so tedious to do in the first place. So, to sum up, we now have convenience factory methods for both creating immutable collections directly and by copying. This approach not only leads to truly immutable collections with good performance, but is also less verbose, and it doesn't require static initializer blocks. And we should make collections immutable by default and only add mutability when needed. This is good because we don't have to worry about leaving behind references to the underlying collections. And this approach is also thread safe, so we can share the collections freely, no need to make defensive copies or anything like that. And performance is better, no need to support immutability anymore in the underlying collections. And also remember that this applies to streams as well. We now have collectors to immutable collections too. Now let's recap some antipatterns that we've observed, so things that we shouldn't do. Basically, don't use legacy workarounds for making the old school collection creation approach one-liner. So don't obtain collections by piping data through other data structures like arrays or stream. Don't pull in external dependencies only to obtain immutable collections because all this has been superseded by the methods directly in the JDK. And especially don't use the instance initializer construct in an anonymous inner class. It's not readable and you're risking memory leaks. And finally, be careful about prioritizing performance over cleanliness of your APIs. Of course, what they did here and why they did it was good, right? This is one of those rare cases where you have a massively used API where any small performance decrease is unacceptable. But in general, I would say this is an anti-pattern. Most likely, your API is not in the same situation as the collections API, and you probably want to favor cleanliness and readability and maintainability over performance at the level of your API. So think carefully about making the opposite decision. So those were anti-patterns. In terms of patterns, so things that we should do, we've seen the pattern of using static factory methods to create objects, right? Of entries, copy of. That's a good pattern overall, and often better than using a constructor directly. Because it allows you to name the methods. The constructor always has a fixed name. So if you have several methods that create objects in different ways, you can easily distinguish between them and avoid overusing constructors. Note the concise naming of these factory methods too, particularly the word of. It's a convention in Java to name static factory methods that way. You'll find of methods in many places in the JDK, and it is a good name to use in your own code as well. Remember the situation where we had immutable implementations of collections, but the concrete classes were not a part of the public API, and the only way to obtain them was through static methods on the interfaces returning their instances. This is a very nice design pattern that enables the implementation to change in the future. Don't be afraid of static imports. It's a good practice to perform them, provided they don't reduce readability, as was the case of map entry. And note the trick that we used with map of entries, right? We needed multiple varargs, which is not possible, so we used the wrapper object, map entry, and created a convenience method to generate it, which was also called entry. Remember that you can use copyof to not only create copies, but also convert between types, such as a list and a set. That can be useful. And last but not least, and this is an important one, it's a good practice to create immutable objects by default, pretty much universally. And now it's easy to do with collections, including when you're creating copies and collecting in streams. So this brings us to the second part of this talk, which is Stack Walker. Stack Walker is an API for easy, lazy, and stream-friendly access to stack traces. Now, before Java 9, what would you use to access a stack trace? Any ideas? Sorry? Okay, any better ideas directly with the JDK? Yeah, exactly, pull it out on an exception. Very good suggestion. On the throwable, you can call the getStackTrace method, which gives you, as you can see here, an array of stack trace elements. An alternative would be to do this on a thread. If I obtain a reference to my current thread, I can call the getStackTrace there. And these were pretty much the two main ways that you can obtain a stack. So this is my stack at this point in time. There are a couple of issues with this approach, though. First of all, it's pretty expensive. The JVM actually needs to eagerly capture a snapshot of the entire stack, essentially for consistency reasons. There's also no easy way to filter these. You basically have to go through everything, even the items that you don't care about. And you cannot access the actual class instances of the classes declaring the methods. Everything is a string here. On top of that, there's not even a guarantee that you're seeing the entire stack trace. The specification actually says that the JVM can omit certain elements for performance reasons. But now, the new Stack Walker API fixes all these issues. The API is built around a class called Stack Walker. And the API is actually very simple. I can obtain an instance of the Stack Walker, and then I can call the main method there, which is the method walk. And the method walk allows me to essentially manipulate stack traces as streams. So I can, for example, just collect this stream, let's say to a list, and forgot a bracket here, but this is my stack at this point in time. You can see that it's very similar to what I got from the getStackTrace method. But now, thanks to the fact that we can use streams here, we can do a bunch of cool things. Actually, one thing that I want to point out first, you'll notice here that the walk method does not return a stream, which is maybe what you would normally expect. Instead, as an argument, it takes a function on a stream. So you can sort of use streams internally here when you're calling it rather than on top of it. And this is important, and we'll talk about why. But anyway, I can do many cool things here. For example, if I was only interested in stack trace of depth 3, all that I need to do here is use limit from the streams API, and these are the top 3 elements of my stack. I can also access the actual class instances of the classes declaring the methods. All I need to do here is tell the Stack Walker to retain class references, and then I'm just going to remove this limit here. I'm going to replace it with a map to extract this information. So I can say, okay, for each frame, quick lambda here, give me the declaring class. And this is the list of all the classes participating in my stack right now. So to recap, what have we seen here? Well, with Stack Walker, you can now take advantage of the stream API to lazily access only certain elements of the stack. Be aware that there are configuration options available. We've seen the one that allows you to retain class references, so don't resolve classes manually by name. There are other options as well. We can, for example, show hidden or reflection frames. As for antipatterns, don't use the old getStackTrace method when doing any processing on the stack. There is a time and a place for this method, of course, such as when you're throwing an unrecoverable error. But more often than not, especially when you need to do any sort of processing, you want to use the Stack Walker instead. Don't treat the stack as text, which is what the old approach did. Use a better structure, like the new approach does. In particular, don't use strings to represent class instances. Don't eagerly access whole things when you only need parts of them, which is one of the main issues with get stack trace. Avoid hidden behavior. Your API should be clear. Remember the omitting of elements for performance reasons. As for patterns, let's think about why the Stackwalker API felt so pleasant to use. Well, first of all, we're using collections and streams instead of arrays, which is what the old approach did. That already is a nice upgrade. Related to that, choose the right data structures and object representations in general. In particular, it can sometimes be tempting to model everything as strings because they're easy to deal with on our side as the provider of the API in a very consistent way. But they can make things harder for the consumer of their API because then they need to deal with conversions or lookups or whatever is necessary. This is the major problem with the old approach. Improve performance by utilizing lazy access to elements through streams. We saw an interesting pattern of a method walk, right, which was accepting a function on streams as an argument rather than returning a stream so that you can sort of chain things onto it. This was done to maintain consistent state and control, and it's a good pattern if you want to use streams but have this kind of requirement on consistency. We also saw the pattern of obtaining configured instances through static factory methods parameterized with enums. In our case, that was the get instance with the optional option parameter. That's also a very generalizable pattern as well. And we haven't talked about that too much, but the Stackwalker API actually also works when running with a security manager, so that access to class objects in stack frames doesn't compromise security. There's even a performance optimization where permission checks are performed when you're constructing an object rather than using it, and that's a good pattern as well. Potentially an important thing to keep in mind, depending on what kind of stuff you work with. Most of us probably don't have to worry about the security manager too much. And that brings us to the third part of the talk. And the third part is, of course, the process API. So the process API, in my opinion, is one of the most underrated features that was added in Java recently. I personally felt the benefit because I had to deal with a similar problem before. I had to write it myself, and it was not pleasant, let me tell you that. The new process API primarily focuses on essentially giving us a way to obtain information about processes. Now, before this, since Java 1.5, we had the old Process Builder API, which allowed us to launch native processes. For example, if I wanted to list, let's say, all the Java processes running in my operating system, I would do it as follows. I would create a new process builder. I would give it a command, in my case, JPS, lists all the Java processes, and I can start the process, and this starts a native process. And this is good, but the main problem with the Process Builder API was that it was essentially very limited, especially when it comes to obtaining information about processes. There was no clean way to do even very simple things, such as obtaining the PID of the process. It is available now, as you can see, but it wasn't available before. So what people ended up doing is either do it through MXBeans, which is pretty hacky, or they would essentially write their own tools that often used sort of native utilities of your operating system. So you would like find information about your process from the outside, let's say by calling something like ps and grep. But that also is unnecessary, and it's, of course, not very portable. And this kind of functionality is important to have nowadays, right? We're often dealing with tools that offer like various solutions for automation. They need to deal with processes written in various programming languages, or maybe you have Java microservices that call some Python scripts in the background, things like that. So it's very useful to have this as part of the JDK. Now, of course, there were better alternatives in the past than the process builder. I think we can easily prove that. How many of you have used the raw process builder directly before? About 5 people. I think that says it all. Of course, what you typically do is use an external library, right? A very, very popular choice is, of course, Apache Commons exec, and that gives you very similar functionality, but in a much friendlier way. And we can actually demonstrate this quickly here. I can just create a new executor and call the execute method there. And to actually call JPS, I'm going to parse it from the command line here. And let's just say JPS. And this works nice and easy. And you can see that it's already a little bit better, right? It gives you a nice return value. It gives you the output by default. And it's actually also really flexible in terms of dealing with arguments and being made to run asynchronously and things like that. There are, of course, disadvantages. Again, this requires an external dependency. And whenever you're pulling external dependencies, especially when it comes to stuff that's sort of external to the JDK, there are portability concerns. Of course, Apache Commons is a very widely used library, so it's pretty battle tested at this point, but the concern is still there. It is actually a pretty old library, so it doesn't play nice with some of the newer constructs in the JDK. For example, it doesn't do asynchronous with completable future, which is how you should do async in Java. So that's a bit annoying, and it kind of increases the surface of what you need to understand when you're working on the code base that uses this. But thankfully, all this is in the past, and obtaining information about processes is now straightforward thanks to the new API built around an interface called process handle. A process handle is an abstraction of a native process, and it allows you to do quite a few things. I can use the process handle to obtain a handle to my current process, and then I can easily extract things such as the PID. There's all sorts of other information available as well. We can check it here. You can see that there are a bunch of things here. We have a user, we have runtimes, we have the command that was used to launch this. There are sort of convenience methods for everything here. So if I wanted to just extract the command line, I can just do this, and you can see that this is how I launched my JShell. Now, of course, I'm not restricted to the current process. I can access information about all the processes that are visible to me. That's easily done by using process handle all processes method, which actually returns a stream. So I can, for example, use a map to extract some information here. Maybe for each process, give me the info and give me a command, and let's collect it, let's say, to a list. And now this gives me a list of all the commands running in my operating system right now. Another very cool thing, which is actually a very common thing that you would want to do with an API like this, is triggering actions on process termination. And that's done here through the onExit method. So let's create a new process here. I'm going to call a new process builder and give it a command. Now let's give it something with predictable runtime, maybe just sleep for 3 seconds. And what I'm going to do here is I'm going to start the process and then immediately obtain a handle to it. And here I'm going to call the onExit method. If we take a look here, you can see that the onExit method actually returns a completable future. So I can use any number of the methods available in the completable future class. For example, then accept, and I'm just going to print it out here. Quick method reference. So just to recap, what I'm expecting to happen here, I'm creating a new process. This is going to return immediately because it's all asynchronous. I expect the process to run for 3 seconds. And 3 seconds later, when the process completes, I'm going to print the process handle. And the toString method on process handle basically prints the PID. So we can try this here, and you can see returns immediately, completable future is marked as not completed, but 3 seconds later, we see the PID of the now dead process appear. And that's very nice and easy, and like a really useful thing that we have in this API. Of course, we don't have to limit ourselves to management of single processes. You can create whole pipelines in the sense of Unix pipelines, where you sort of connect the output of the previous command as the input of the next command. That's easily done here. So let's say if I wanted to list all the Java processes running in my system and then find JShell here, I can easily create it by creating a process builder for my favorite command, JPS. And let's call this JPS. And I'm going to create a second process builder, which just calls grab and grabs for JShell here. And let's call this grab. And now, to actually construct the pipeline, I'm going to call process builder start pipeline, which takes a list of process builder. So I can immediately take advantage of Java 9 static factory methods here. And I'm going to give it JPS and grab. And let's call this pipeline. And now, of course, this is all asynchronous. So this tells you that this hasn't exited yet, but of course it completes very quickly. We can see now that everything finished successfully. So now let's try to actually read the output from this pipeline. So all I need to do here is get access to the last process in my pipeline, and there's only 2 of them, so that's index 1. And then I can open an input stream to its output, and I'm just going to print it out. So let's just transfer it to system out. And you can see that we actually found a process here. It's called JShell tool provider, and that's the process that runs JShell. So very nice, nice little API here. So to sum up, remember we now have the process handle interface, which gives us a very clean way of obtaining information about processes. It's a very nice and fluent API. We can take advantage of the convenience methods there, like PID, info, command. You can now trigger actions on process termination through the onExit method and the completable future that it returns. And you can connect the old process builder API to the new process handle API through the new toHandle method. As for antipatterns, it's now an antipattern to use JMax and external utilities of your operating system to obtain information about running processes from your Java code, simply because there's now a better way to do this directly with the JDK. Similarly, don't pull in external dependencies for process management unless you need something really specialized. For the simple stuff, an external dependency would just increase the surface that we need to understand as developers. So, just use the JDK while you can. What made the old process builder API hard to use was the fact that even though we could use it to start native processes, there was no functionality to manage them or even obtain information about them. And that left developers with implementing their own solutions, which typically wasn't portable. And because portability, it's hard when you're dealing with things that are external to the JVM. So keep portability and completeness in mind when you're creating your APIs too. Some interesting patterns that we've seen here. It's a good practice to provide convenience methods in your APIs for commonly used functionality. We've seen it with process info, methods like info, PID, command line. It made the API really pleasant to use. We saw the pattern of using fluent APIs to access nested information. So in this case, we didn't have the standard, getter methods to deal with the process info. The API was more fluent, and as you've probably noticed, I'm a big fan of fluent APIs in general. This API emulated the structure of the data by using nested public interfaces to group things, such as the info interface. And we saw that that worked pretty nicely and was actually pretty easy to understand as well. We also saw the pattern of providing convenient static factory methods to obtain various instances of process handle. This was essentially much cleaner than overusing constructors for this. Constructors would all have the same name by definition. With static factory methods, like we said before, we appropriately named them to be able to distinguish between them. There was also an interesting use of streams here. You may have noticed that there were several methods that didn't return collections, which would be more common, but they actually returned streams. And this is a bit tricky. I wouldn't necessarily recommend this as a pattern when passing things sort of across API boundaries, because collections are easier to manage. Streams have state, so you can run into things like the stream is closed or things like that. But it is a nice pattern to allow for lazy processing of many things. Also note the pattern for building asynchronous APIs by returning completable future instances. That's simply the way to do asynchronicity in Java now since Java 8. So yeah, that's just how async should be done. And we saw that in action with the onExit method, of course. There was an interesting use of the adapter pattern too, by providing two methods to do the conversions, such as when going from process builder to process handle. Also very nice and useful. And this brings us to the final part of this talk, which is the new HTTP2 client from Java 11. Now, the new HTTP2 client is not just a cleaner alternative to the old HTTP URL connection API, but it also supports all the cool new things. It supports HTTP2, of course. It supports WebSockets, TLS, server push, proxies, cookies, basic authentication, basically everything that you would expect from a mature HTTP client. Now, the client is very easy to use, but to demonstrate the functionality of the client, I'm going to need a server. And if there's anything that I've learned from doing live coding at conferences is that you can never rely on the Wi-Fi there. So what I'm going to do here is create a very simple local server just with Java. I actually really like this example because I think that many people don't realize that we have this kind of functionality available in the JDK, but it is there and it's not a new API. We've had this for a very long time. So I'm going to create the simplest possible server here. It's going to have a single endpoint, and no matter what kind of request I send to this endpoint, it's going to respond with a fixed string. So to do that, I'm going to start by defining the handler for my endpoint. So let's call this handler. And this is going to take an HTTP exchange and do a quick lambda here. Actually, it's going to need a multi-line lambda, so not so quick and not exactly clean, but good enough for our demo. So I'm going to start by declaring the string that I want to return. Let's call this body, and let's put some string here. Let's say hello, Devnexus. And then I'm going to take the HTTP exchange and set the response headers. So I'm always going to respond with 200. Everything is OK. And the length of my content is going to be the length of my string here, just like this. And now, finally, I'm going to use try with resources. I'm going to open an output stream, attach my response body to it. And now I'm going to use the output stream to write my string to the actual body of the response. So my string is called body, but this is a raw output stream, so I need to convert it to bytes, but that's OK. And one more bracket here. And there's a little bit strange stuff going on here with the auto-completion, but we can take a look here. This is my handler, and looks pretty reasonable. So now, let's try and create the server here. So I'm just going to call HTTP server create, and this needs a port. So let's give it a port, let's say 8000, and don't need the backlog, and let's call this HS. And now finally, I can create my endpoint here. Let's say /hello. I'm going to attach my favorite handler to it. And now I should be able to start the server. So hopefully the server is running. But to test this, of course, I'm going to need a client. So let's first try and do this the old way, using the HTTP URL connection first. So with the old API, I would start with creating the URI. So this is going to be a URI pointing to my local server. So it's going to be something like HTTP localhost. I think I used 8000 /hello, and let's call this URI. Now, I'm going to convert this URI to a URL so that I can open connection on it. And if I take a look here, you can see that this returns something called URL connection. But that's not what I want. What I want is an HTTP URL connection. So what I need to do here is actually cast it to HTTP URL connection. So you can see that we're just starting to write the client, and this is already getting pretty unpleasant, right? I need to perform a runtime cast just so that I get the right instance of the connection I'm looking for here. So let's call this C. Now, I need to set the request method here. Let's say I'm going to do a GET request. For some reason, this is passed as a string. Again, not particularly pleasant. And now, finally, I should be able to check the status code, which is called response code here. So let's see what we get here. OK, 200. So this is looking promising. So now let's try to actually read the body of the response. So to do that, I'm going to open an input stream on the connection. And then to be able to read from it, I need to use sort of standard, Java 101 boilerplate. I'm going to probably need to wrap it in an input stream reader, just like this, and we'll wrap this whole thing in a buffered reader, just so that I have the method read line available here so that I can read this. And you can see that it does read the correct string. So we have a working HTTP server, thank you, working HTTP client. They can all talk to each other, but you can see that it wasn't particularly pleasant to get there, particularly on the client side of things, right? Things were a bit annoying. Now, there are, of course, alternatives. And if you were writing this and you're not on Java 11 yet, you probably wouldn't use HTTP URL connection directly. And there is a reason for that, right? Again, let's just do a poll. How many of you have ever used HTTP URL connection directly? Yeah, probably, let's say, 10 people out of, I don't know, 150, 200. I think that really says it all. So yeah, there are alternatives. We have a little bit of time, so we can take a look at maybe some of them. A very popular choice, before Java 11 was, of course, another Apache library, the Apache HTTP client. Of course, there are many other options. You probably use Retrofit or whatever, something more modern. But Apache HTTP client is kind of the go-to library and has been for many years. So with this, with the Apache client, the situation would be much simpler. All we need to do is create a new client here. We can just keep the default settings here. And let's call this the client. So we're just starting out, and already you can see something interesting, right? We're not doing everything through a URL connection. We have a nice separation of concepts. We have a class dedicated to the client, and similarly, a request and response, as it should be. So to create a request, I'm just going to make a new HTTP GET request and give it my URI that I have from before, and let's call this request. And now finally, I can use the client to send the request, which in this case is called execute, to my server, and this returns a response. So now we can take a look here at the protocol version. You can see that this is HTTP 1.1 client. Of course, if we take a look at the status line and extract the status code, you can see that this is 200. And we can also, of course, read the response. Now, this is a little bit annoying. Of course, they need to be very flexible, so they need to support all the possible content types. So it's actually the method to extract the body is called getEntity here. And to be able to parse it as a string, I'm probably going to do something like this: entity utils to string, and giving this, and you can see that we have the right string there. So the names, particularly on the last line, are definitely interesting. You know, entity and entity utils, it's hard to imagine more vague names for things. So that's probably one argument that you can make against the old HTTP client, but otherwise it works pretty much universally better than the old HTTP URL connection. But now, let's try to do the same thing using the new HTTP to client API from the JDK. Now this API, similarly to the Apache client, is built around the three main classes, which are HTTP client, HTTP request, and HTTP response. Pretty self-explanatory, right? So let's start by creating the client, and I'm just going to do new HTTP client here. Let's call this client. I can take a look here at the version, and you can see that this is HTTP 2. Of course, I'm not really taking advantage of this. I'm only talking to my very simple local server, but the functionality is available there. So now I can construct a request, and this uses the builder pattern here. So I can just obtain a new builder, give it my URI from before, make it a GET request, nicely as the method here, and call build, and let's call this request. And now finally, I should be able to use my client to send the request to my server here. And this also needs something called response body handler here. In this case, I just want to tell it to treat everything as a string, and thankfully there is a built-in handler for this, which is called offString. So that's all I need. And let's call this response. And now, to obtain the status code, I just call the method status code. To obtain the body, I just call the method body. Everything works nice, easy, and very clean. And this is very flexible as well. For example, if I wanted to make this asynchronous, all I need to change here is the send to send async, which now, of course, returns completable future, as it should. So we call this response. We can extract the value from the completable future and then call body, and this works exactly the same. Very nice and very clean here. All right, so to recap, what have we seen here? Well, what made the new API really pleasant to use was essentially how clearly it was organized, particularly in comparison with the old HTTP URL connection. We had three main classes: HTTP client, HTTP request, HTTP response, and they're pretty self-explanatory. Don't use HTTP URL connection. It's not fun. Use the new client API instead. It's very versatile, flexible, and clean. In general, if there is good functionality available in the JDK, as is the case of the HTTP client now, prefer it to external libraries. Again, you're minimizing the surface of what people working on your code need to learn. As for antipatterns, well, using HTTP URL connection directly. You should use the new client now, of course, but if you can't for whatever reason, it would be a good practice to use something else, such as a third-party library. We've seen the Apache HTTP client in action. There are many other popular options out there. Inconsistent capitalization is also a problem. I always find it very hard to remember that URL should be capitalized and HTTP should not be, right? Always be consistent when it comes to naming and capitalization, especially when you're dealing with abbreviations. A convention in Java is to use sort of strict camel case. So even with abbreviations like URL, it would be like uppercase U and lowercase RL. As developers, we like to generalize things, but overly abstract and general APIs can be very unpleasant to use. Like, why do I have to deal with a URL connection when everybody uses HTTP and wants to work with an HTTP URL connection, right? Now, it is a bit tricky with the old URL connection API, because that API is very old. It actually predates HTTP 1.1. So simply put, HTTP has evolved, and this old Java API is now too abstract partially as a result of that, but the point still stands. One thing you should always strive for when designing APIs is a clear conceptual model that allows the client to predict the effects of their actions. That's one of the big issues with the old URL API. Because URL is so generic, it doesn't have a clear conceptual model. At a minimum, it mixes two things. It mixes an abstraction of an address and an abstraction of the client that reads from it and writes to it. Those should be separate things, and they are with the new API. Remember how when we called open connection, it gave us a URL connection object, which we immediately had to cast to HTTP URL connection. Having to perform a cast to obtain a useful instance, that's a big no. And URL connection is actually an abstract class, so we basically always need to cast it, risking runtime errors. Now, that might have made sense in the early days of HTTP, but most of these other protocols that they were trying to support with this abstraction are now dead, and HTTP is by far the most widely used protocol. So it would have been much better, if nothing else, to at least have a convenience method that gives you HTTP URL connection directly. Using strings where methods or enums would be more practical is also an anti-pattern. Compare how we set the request method in the old API, that was a string, versus the new API. Again, perhaps that's the cost of the generalization, across multiple protocols, but still, it is a point. IO boilerplate, also not good. Remember how just to read a line from a connection, I had to obtain an input stream from the connection, then wrap it in an input stream reader, wrap it in a buffered reader. Not pleasant to do. Speaking of IO, mandatory blocking IO is also a problem nowadays. The old API works in blocking mode only, so one thread per request response, which maybe that was an acceptable practice at the time, but nowadays this could be considered an anti-pattern. And probably the biggest issues of them all, side effects and hidden assumptions. Avoid this at any cost in your APIs, please. What I mean by side effects is essentially what, you want the API to do what it says it does. Otherwise, things get very confusing for the clients and us as developers. For example, if you have a getter, you expect it to just read something. You don't expect it to write something to change the state in any way. But that's exactly what the old API does. And there are many, many examples of this, but a really painful one is the method getInputStream on the HTTP URL connection, which also has a side effect of writing, actually sending the request to the server. And that's very unfortunate. An example of hidden assumptions, with the old API, it's also illegal to attempt to set a request property after obtaining an input stream, but that's unclear from the Java doc. So there are hidden assumptions like that which make the API hard to use. What makes this even worse is inconsistent behavior across APIs. Java has a socket class, which is actually used by the URL connection underneath, and confusingly, they both have getInputStream and getOutputStream methods, but they behave very differently. The socket versions don't, for example, suffer from side effects. So even if you're used to working with the socket API and then sort of move on to a different level of abstraction with the URL connection, you'll be very surprised at how it works, or doesn't work, rather. As for some patterns that are nice in the new API, note the clear separation of concepts. Separate classes for the client, request and the response, that made the API very pleasant to use. Note the use of the builder pattern all over the place, also very clean. Using completable future to do async, like we said before, that is the correct way to do async in Java nowadays. You may have noticed that the new API pays a lot of attention to naming things. Everything was very clearly named. You look at the name of a method or a class, and you know exactly what it's about. No need to even read the Java doc, which is very different from the old HTTP URL connection API. You're basically lost with a Java doc there. And also notice that, similar to the process handle API that we saw before, the new HTTP client also heavily leverages the pattern of providing convenience methods to access common things, also in a nice, fluent way, which makes it very easy to use. And that's it for me. I hope you learned something, and if you have any questions, I'll be around after the talk, so just come up and say hi, and otherwise enjoy the last couple of hours of the conference.